good afternoon, everyone. Before we start the second session, this is a agenda reminder that taking photos and video are not allowed during the presentation. And okay, our next topic is enhance heat and oil resistance in thermoplastics vulcanizators based on modified natural rubber and fluoropolymers brands. Please welcome Dr. Subhan Salaeh.
Okay, thank you very much. So, thank you to join my presentation. So, the topic of my presentation today is enhanced heat and oil resistance in thermoplastic vulcanizates based on modified natural rubber and fluoropolymers blend. So, thermoplastic vulcanizate is a class of thermoplastic elastomer which can be prepared from blending between thermoplastic and elastomer using dynamic vulcanization process. So, after dynamic vulcanization, so we can see that the crystalline rubber will be dispersed in the thermoplastic matrix. So due to this structure, so we can obtain the material TPE or TPV, which can behave like a rubber-like material. So it has high elongation at break, low modulus, and good elasticity. And another advantage of this material, if we compare with conventional rubber, so this material consume lower energy. So this can be prepared from thermoplastic and elastomer. But at the same time, in the case of the rubber, we need many additives to prepare the rubber vulcanizers. Moreover, we can see that the rubber scrap cannot be recycled. But in the case of thermoplastic vulcanized, the TPV or TPE scrap, we can be recycle them. So it is like sustainability and recyclability. So this is the advantage of the TPE or TPV. So the thermoplastic vulcanizers can be divided into three groups, but they can be prepared by various types of thermoplastic and rubber. But for example, the first group is olefin-based TPV. So the olefin-based TPV, it can be prepared, they are used for general purpose, but they can be prepared from the polyolefin like polypropylene, polyethylene, ethylene vinyl acetate, and natural rubber and synthetic rubber like natural rubber, EPDM, butyl rubber, and SBR. And the second one is bio-based TPV. So this TPV is eco-friendly TPV. So usually they prepare from biodegradable polymer and bio-based rubber like polylactic acid, caprolactone, and so on. So the third one is super TPV or high performance TPV. This TPV exhibit high good heat and oil resistance. So this TPV can be prepared from polyamide, PVDF, and a specialty synthetic rubber like acrylic rubber, nitrile rubber, and FKM. So how about natural rubber? So we can prepare TPV from natural rubber. So this is the purpose of this work. So we focus on the fluoroplastic like PVDF because the PVDF is engineering thermoplastic and it has good solvent resistance, weathering resistant, and also has good electrical properties. So it has two fluorine group in their structure. So that's why it has good good weathering properties. Therefore, it can be used for various type of composite and blend. So it can be blend with the polyamide, PMMA, and acrylic rubber. So in order to blend with the natural rubber, so we modify natural rubber with methyl methacrylate or polymethyl methacrylate. So we craft polymethyl methacrylate with natural rubber using emulsion polymerization. So we can we have PMA group here. So this PMA group will exhibit good interaction with the PVDF. So after that, we use this rubber for blending with PVDF. for simple blend and thermoplastic vulcanizate at 180 degrees C. So this is the morphology after blending MGNR acrylic rubber with the various amount of so we have 5, 30, and 40. So this is amount of PMMA. So with increasing of PMMA group, so we can see the fine dispersion of morphology due to the good interaction between PVDF and acrylic rubber. So both simple blend and TPV. So this is due to the compatible interface between PVDF and acrylic rubber. And also this is the dipole-dipole interaction between acrylic rubber and PVDF. So that's why blending PVDF and acrylic rubber show good morphology, and then it show good the properties. So as we increase the high grafted PMA content, we can increase the tensile strength and elongation at break due to the fine morphology of this blend. And the miscibility can be confirmed by DSC. You can see that crystallinity decrease with increasing of PMA group. So at the beginning, PVDF has 55% of crystallinity, but when we blend with MGNR, we reduce the crystallinity to 50%. And therefore, we studied the another work last year that we prepared the ternary blend by adding FKM. So we add FKM because we want to increase the heat and oil resistance of TPV. So we study the effect of dynamic vulcanization and blend ratio, and then we vary the amount of PVDF 50, 40, 30, and we also vary amount of FKM and MGNR from 100, 0, 75, 25, 50, 50, 25, 75, and 0, 100. So this is the result, and when we increase, so we can see that on the left hand side is binary blend, is only PVDF and MGNR, and the right hand side is only PVDF and FKM, and we can show that ternary blend show better property than binary blend. It is due to the good interaction between FKM, MGNR, and PVDF. So the good interaction is from dipole-dipole interaction between acrylic rubber, PVDF, and FKM. So that's why we improve the property for the ternary blend. And also on the left hand side is only PVDF and acrylic rubber, and the right hand side is only PVDF and FKM. We can see the large PVDF domain for the binary blend of PVDF and FKM due to the different viscosity. But in the case of PVDF and MGNR, we can see the good dispersion of MGNR in the PVDF due to the interaction. And also for the ternary blend, we can see the fine dispersion of FKM, MGNR, and PVDF. This is the combination with the three components in the TPV. So the whole is the extraction of the MGNR with the toluene. So we can see that the ternary blend show the good morphology as compared with the binary blend. So, and then this is TM morphology. So on the left hand side is the simple blend. So the dark side, the dark phase is PVDF, and the bright phase is MGNR and FKM. So it's difficult to classify. But after dynamic vulcanization, we can see the phase inversion and the difference between simple blend and TPV due to the curative agent in the TPV, which is diamine. So we can see that the PVDF become the metric phase, and the FKN and MGNR become dispersed phase for TPV. So, and this is only PVDF and FKM. It show large morphology due to viscosity mismatch between PVDF and FKM. That's why it shows large morphology and low mechanical properties. And we can see that ternary blend show finer morphology as compared to binary blend. And also this DSC show the lower crystallinity and melting temperature due to the addition of acrylate rubber into the TPV. And this is the DMA curve. So we can see that the TG of each component in the TPV. So, but usually we can see that the shifting of the TG of each phase which is due to the miscibility between the blend component in this TPV. So, and then we can see that the ternary blend show the higher modulus than binary blend due to the good interaction between PVDF, FKN, and MGNR. And this is the heat resistance. So we can see here in this table with increasing of FKM, so we increase the onset temperature and temperature at 50% loss. So with increased FKM, so that means we can improve the heat resistance of TPV by adding the FKM into the TPV. And also we can see that the oil resistance is better when we increase the amount of FKM and PVDF. So this TPV show small swelling in the toluene, diesel, engine oil, even at high temperature. So it means that we can improve the TPV by adding FKM and PVDF. And also this TPV also can be recycled. So it is like thermoplastic, but at the same time it exhibit like good elasticity like rubber with high elongation at break and good elasticity. So it means that we can prepare the new thermoplastic vulcanizate by using modified natural rubber and FKM. So this TPV can be improved by PVDF. So it improves strength and recyclability, and FKM improve elasticity and oil and heat resistance. And acrylate rubber, we can improve the morphology, elasticity, and sustainability of the TPV. So thank you very much for your kind attention. So if you have any question.
Okay, let me introduce myself. My name is Ronnie from PT Vlasto Indonesia. I want to ask about the modified and natural rubber. Is it
Yes.
already conventional material, commercialized material for this, or we need to make it ourselves?
For this one, I made by myself. No, my researcher. We made it in our research group.
So currently
But
there is
there
no.
is some companies sell this rubber, but in our case we use 40% of PMA. So, but in the commercial maybe they have only 30%. So, but in our case we use 40%. So exactly, it's not difficult to prepare this one.
Okay. Thank you very much.
Anyone have any questions? We still have times.
You have any question? No.
Okay, all right. If you don't have any questions, thank you so much for Dr. Subhan for us to be speakers for
Okay,
today.
okay.
And if you have any question or you would like to meet our speaker, please go to the booth number B23.
23.
Yes. Thank you so much.